How's it going? Up, middle, down for this test. Middles, middles. Okay, I'm relieved it's more middles than downs. So we're starting from a good place. Okay. So I'll go over the practice problems that Dr. Lee put up. And then if you guys have any questions about the chapter 16 or 17 homework, I know it's due tomorrow. So if you have questions about that, we can look at those after the practice problems. Sound good? Okay. So first practice problem. Describe the primary, secondary, tertiary, and quaternary structures of proteins. Where do we start? What's our primary structure look like? The sequence of amino acids. What about secondary? I'm looking for the kind of structures they make and what kind of bonds make them. Hydrogen bonds, yes. What do they make? Alpha helix, beta sheet, and then sometimes you'll get a disordered or unstructured loop. Tertiary. What is interacting with our tertiary? What part of our amino acids? R groups. What kind of bonds or interactions are our R groups making? Yes, that's one. What are the other two kinds? If you hate water, hydrophobic. If you shuffle across a carpet and shock someone, electrostatic interactions. So these are the three types of interactions you should know with tertiary folding. And that's where your alpha helices and beta sheets will start holding together. What about quaternary? What's the main gist of a quaternary structure? Multiple subunits. How are they coming together? What kinds of bonds or interactions? I'll give you a hint. We've already said them. I feel like I heard the right answer. No? No one? Okay. Hydrogen bonds are going to be one of them. Can anybody name another one? Hydrophobic is going to be another one. There's one more. It is electrostatic. So those are our 4 levels of protein folding. Do you guys have questions on that? Yeah. Yes, they will all already be folded tertiarily. And then when they come together, that's a quaternary structure. What's up?
So do we start in the 3D structure? Is it the 2-prong or 3-prong? 2-prong or
2. Yeah, so that's when you start getting the helices, and then the beta sheets are kind of like bumpy. Usually when they're in 3D, they'll be drawn like an arrow, and then you'll have a disordered region, and then you'll have an alpha helix. Yeah.
Would something like this, like, do you expect us to write out sentences like this on the exam, or is it gonna be more of like a multiple choice?
This would probably be more of a multiple choice question. I think when you're looking at what kind of short answer questions you'll have, they're like the ones we've done prior, where it's more of a focus on structure and drawing rather than having to like write full sentences about anything. Other questions? Cool. Why do proteins fold? Any thoughts? Exactly. How does folding maximize stability? Yes. So we're going to keep like with like. And by that, I mean our non-polar regions will come together. Non-polar. And our polar regions will come together. And that comes down to hydrophobic versus hydrophilic. What's up?
the tertiary structure?
Mhm.
The tertiary structures. When I was looking through the homework and stuff, is a salt bridge, is that electrostatic?
Yes. So a salt bridge is where you have like a chloride ion, and they're charged. And so that's where you get the electro part of it.
What about dispersion forces and hydrogen bonding?
Hydrogen bonding, it also occurs with tertiary. We mostly see it initially with the secondary, but yes, it does occur with the tertiary as well. And then dispersion forces are really weak. They play a lot less of a role, and they can kind of be lumped in with other interactions.
Is that technically the hydrophobic ones?
It can be, yeah.
So what's the difference between all those? Are they all the same, or is that?
They're all the same in that they're all interactions that bring certain parts together of the like amino acid chain itself, but the chemistry behind each of them is different. So a disulfide bond, that's literally a covalent bond between sulfurs. And that is going to be really strong. That's why we've talked about that one a lot with like hair perms and stuff. And then hydrophobic interactions, that's like your nonpolar areas will want to stay with the other nonpolar things because they're all hydrophobic. And then electrostatic, that's where you get charges that are kind of interested in staying together. Mm-hmm. Other questions? Okay. So for serine and alanine, these are 2 of our amino acids. How many possible dipeptide combinations can be made? 2. What's the like numerical rule for dipeptide, or not dipeptide, but for general peptide combinations? Like if I said you have 6 available amino acids. Yes. That's your general rule. So, draw the reaction for the formation of one of the dipeptides. What kind of reaction do we have to do? It might be easier to start with C before we do B. There's 3 correct answers here. They all mean the same thing, but they're different words.
Condensation.
Condensation is one, yeah. Yes, condensation. Acidification. And the last one is kind of in the name. We'll make a peptide bond. So, how would these two come together? Where will they connect? What are the key functional groups here? Yes, the amine and the carboxylic acid. So we can take our structures in a condensation reaction. What is one of our byproducts always? Water. So we have to figure out what from these 2 molecules we're going to take away to make that water. Anybody have any thoughts? We're going to take a hydroxyl group and one of our protons on the amine. So that is our dipeptide. But in D, what does the dipeptide look like at a pH of 12? What does that pH of 12 tell us? Yes. So it should have net negative. How can we give this molecule a net negative? Where can we take a proton off? Or where should we take a proton off? Which OH? The C terminal. So we're going to get rid of this proton, and we get a negative charge there. Where's our C terminus and where is our N terminus? C terminus is left or right? N terminus? There's 2 N's here. The one that's on the end. Okay, questions on this aspect? It's kind of a review because we learned about amidifications last unit or last exam. This is just a biological application of one of the reactions we learned. What's up?
Why wouldn't you remove the hydrogen from the other?
The pKa of this OH is different than the pKa of this OH. And what pKa means is that's the pH level where that proton will fall off or return. And so each of the R groups have unique pKas that you don't have to worry about.
Where did you get the 2 from?
It's the factorial. So we have 2 possible amino acids that we're using. So it's 2 times 1. And if we had 3, it would be 3 times 2 times 1. Other questions? Moving on. So for the following polypeptide, we are going to draw the products of acidic hydrolysis of the molecule. What does that mean? What are we going to do here? We're going to break it apart. Where are we going to break it apart? Yes. So we're going to look for these amides where we have a nitrogen and a carbonyl, and we're going to break in between that. So how many breaks should I have here? Where are they? True. How many amino acids does this give us? 4. So when we draw these broken apart, we're going to basically replace the water that we previously had. Now, acidic hydrolysis, what does that mean we're using when we break it up? An acidic solution. What does an acidic solution have a plethora of? Protons. So acidic, we can see H plus, and hydrolysis, we can see the water. So what do I have to change about these structures given that this is an acidic solution? The amines become positively charged. Questions on that?
So for this one and the last one, when you're in positive and negative charge or something, we should only worry about the 2 atoms.
Yeah, the pKas of the R groups gets a little complicated, and I think that's more than you guys need to know for this course. Because then you would have to memorize the pKa for each of the R groups, and sometimes there's more than one, and that's a lot of stuff you don't have to worry about. What's up?
So where did the extra, I guess, protons, is there like a reactant or something that's added?
Yes, so when we say acidic hydrolysis, it's assuming that there's an acid in our water. So we could have like HCl or H2SO4. Those would be acids, but here we're just taking it as a general acid, which for our purposes, we can ignore the stuff that's connected to it and just think about the protons.
What's the scenario where it would be neutral and where it would be basic? Would you say basic hydrolysis or neutral hydrolysis?
Yes. It probably wouldn't say neutral, it would just say hydrolysis. But a basic hydrolysis, you would take off the protons from the carbon terminus of each of the amino acids, kind of like we did in the last one. Questions on this one? For the following nucleotides, first of all, which are these two nucleotides? If you had to give them their letter titles. A and G. A and G. If we were to break down these nucleotides, what are the three components here?
Phosphate, sugar, and
Yes. We have the phosphate, the sugar, and the nitrogenous base. Is this DNA or RNA? DNA, because it's deoxy. What would I need to do to make this RNA? An OH here would make it RNA. But anyway, draw the product of the condensation to form the nucleic acid. How will we connect these two pieces? What's our kind of connecting link? Where does what attach? Yes. Yes, exactly. So we'll redraw. So in a condensation, what byproduct are we making? Water. So we're going to take an OH and an H and connect our phosphates together. So this is our condensation reaction. How many hydrogen bonds would a complementary nucleic acid strand make? What does an AT pair make? 2. And what about a GC pair? So we said that this is A and this is G. What would our A connect to? T. And we would have how many hydrogen bonds there? 2. What would our G connect to? C. With how many hydrogen bonds there? 3. So how many would this total nucleic acid strand make? To take it a step further, where is our 3' end and where is our 5' end? Questions on this one?
What is the two bonds and three bonds, how does that work?
So the complementary structure is able to make 2 hydrogen bonds, whereas here it can make 3 hydrogen bonds. So that's if you had a C drawn out here next to it. This is the last question that was on the problem set. So if you have other questions, what's up? So in this one, you could have drawn it either way. You could have drawn AG or GA, but the 5' end is this carbon that's kind of off of the sugar circle, sugar ring. Because here we have 1, 2, 3, 4, 5. And so the 5 will be the end that's loose. And then the 3' end is on the opposite side, and it's the OH attached, well, it's the carbon center that has the OH attached, which is where a next nucleic acid could come connect. Because these bonds are always 3, 5. What's up?
That last problem, this is problem 4.
Yeah.
It was, so what would it look like if it was a basic hydrolysis? Or is that not possible?
So a condensation, we're gonna make water, and it doesn't super. Oh, for this one, yes. So a basic hydrolysis would just mean that we are taking protons off instead of putting them on. So instead of having the positive, we would have the negative form. And then if it were neutral conditions, we would have this water ion, where it's both positive and negative, but they equal out to be neutral. Other questions?
Can you scroll back to 5, just so I can see the hydrogen bonds?
So the highlighted parts are what would come together. This is the nucleotide or the nitrogen base of cytosine, which is the complement to G. What's up?
When you, when it's talking about it being alpha or beta linkage to the nitrogen base,
Mhm.
and then it has to match that, if the, whatever's connected to the 4', they have to be on the same side. Is there any scenario where they're gonna be on different sides? So it's always just gonna be, they're both on top of it on the.
Yeah. The alpha beta linkages are more for glycosidic linkages, which is like where you have, it's like the chapter 15 stuff where you have like a fructose and a mannose connected and they would have like an alpha or a beta linkage there. It's less so with these because these all need to stack. So they'll all be either both up or both down. Yeah. That's when something else has a higher priority than the alcohol, which is rare and probably will not come up on the exam. But naming is probably a good thing to review for the exam. Other questions? Would it be helpful if I also drew out T for the hydrogen bonding to A? Okay, yes, no, yes, okay. Any other questions? It was a short set of practice problems. So a short office half hour.
But when it comes to drawing for the exam,
Mhm.
in your recipe, obviously without doing anything, like what do you feel like we should practice and like review when it comes to drawing anything?
Reactions.
Reactions.
Because so reactions and naming, because I think the easiest way to test both is to give you a reaction where you're given the name and you are to draw what the reactants are and what the products are. And so that can be a good way to test yourself, is come up with the name of a carboxylic acid and then an amine of some kind and draw the acidification between them, or come up with an alkene and hydroxylated.
What do you think are the best ways to like do that? Going over all the old
Yes.
problems and homework, probably?
I would say going over the old practice problems more than the homeworks, because the homeworks are a little more vague than exactly what is being tested. I would also say go back through your other exams and figure out what you missed. So if you had a question wrong, figure out, okay, did I just guess this answer or did I think I was onto something? And if I did think I was onto something, how was I wrong? And like make sure that you now understand where you were coming from thinking that and why it's wrong now and what the right answer is.
So the questions for the final will be pretty similar to just like the first week.
Yes. And then like the practice problems here. Yeah.
So this is just.
This practice set is just over the new material since exam 3, which is not a lot.
Will we be able to go back to our old tests somewhere?
So you can look on Gradescope to see your answer sheet, and that's where you can see like your multiple choice answers and what you put as the short question answers, and also feedback from me and the other graders about why you got points off where you did. And then you can go back to Dr. Lee's videos where he walks through the entire exam. But there's not just like a PDF of the old exam. What's up?
Did you say it's like evenly distributed between all the materials you learn?
Yes.
Exam 1, 25%. Exam 2.
Maybe not by like percentage, because a lot of what you have been learning builds on itself. But I do think it pulls from first week stuff as well as last week stuff.
So you said you feel like the homeworks are pretty vague, that really.
The like
Help
chapter
us.
homeworks, some of them are helpful, but like 15, 16, 17, when you guys had to like do the blood questions and like it was questions on identify this as fructose and which of these are like that kind of brute memorization is not going to be helpful for the final exam. But if you want to like flip through the homework and see the questions that are like more about reactions or more conceptual in nature rather than like, do you know what cellulose is? Because you don't need to know what cellulose is for the exam. You do need to know how to do an acidification reaction or how to do a condensation reaction or how to know which product is the major product. So that's why I say it's a little less helpful than the problem sets, just because they have those questions thrown in where it's like, did you do the reading?
Okay. You said it's gonna be more of like, I'm sorry to repeat myself, I'm just making sure that I'm on track with you, reactions and like naming and all of that kind of stuff. Is there any, without, obviously giving it away, do we need to know Fisher structures and stuff like that?
I have not seen the exam yet, so I cannot speak to directly what topics will be on there and what won't be. If you struggled with them on the last exam, it would help to like brush up on them. But I don't know for certain if they are or are not on the exam. What's up?
So there's gonna be like no drawings on it, like where we have to draw anything.
There will be drawings. It's like all the other exams where it's you have some multiple choice and then you have some drawing questions. I'm not sure how many in total it is. You might make this one exactly 150 just because it can be a second exam, but I'm not totally sure.
How does that work? So that replaces your lowest exam grade if you do better than that. If you don't do better than that, it's just
That way it can't extra hurt you, but it can help you. Yes, because it is just like a normal exam. I have my normal office hours tomorrow. So if you come up with questions or concerns, I'll be in the ILSB from 3 to 4 at a minimum, 3 to 5 at a maximum. And I'm available by email and Canvas message if you have any other questions, comments, concerns that come up between now and then. But if not, I will see you Thursday at 10 a.m. for your final. What?
just.